Next, concurrency property. So concurrency of internal bisector of the angles of a triangle. The internal bisectors of the angles of a triangle are concurrent. Let A x1 y1 B x2 y2 C x3 y3 are the vertices of triangle ABC. Right? This is the triangle. Let AD, BE and CF be respectively the internal bisectors drawn from the vertices ABC. So AD, the bisector AD meets the side BC at D, and the bisector BE meets the side CA at E, and bisector CF meets the side AB at F. Here let the side length BC equal to small a, CA equal to small b, and AB equal to small c. So side length ABC. We know that from the angle bisector theorem, AB by AC is equal to BD by AD. AD is the angle bisector. Then the side AB by the side AC, which is equal to the length BD by the length DC. So BD by DC is equal to AB length is C and AC length is B, C by B. Implies the point D divides the line BC in the ratio BD is to DC, right? D divides the line BC in the ratio BD is to DC, that is C is to B, right? We know that from the section formula, if the point P divides the line joining the points x1 y1 and x2 y2 in the ratio m is to n, then the coordinates of the point P are given by mx2 plus nx1 by m plus n, comma my2 plus ny1 by m plus n. Here D divides the line joining the point x2 y2 x3 y3 because B is x2 y2 and C is x3 y3 in the ratio C is to B. So the coordinate of D are, so using the formula, section formula, instead of m you are having C and instead of n you are having B. So the points are x2 y2 and x3 y3. So C x3 plus B x2 by C plus B, comma C y3 plus B y2 by C plus B. We know 2-point form of a straight line passes through x1 y1 and x2 y2 is y minus y1 equal to y2 minus y1 by x2 minus x1 into x minus x1. That is equation number 1. So now we are going to find the equation of the internal bisectors AD, BE and CF. So now AD passes through the 2 points A and D. So A is x1 y1 and D is cx3 plus bx2 by c plus b, cy3 plus by by c plus b. So we are going to use equation 1, that is 2-point form of a straight line. So right, so x1 y1 is here x1 y1 only, but instead of x2 y2 in the formula, here you are having cx3 plus bx2 by c plus c, and y2 is cy3 plus by2 by c plus b, right? So equation is y minus y1, which is equal to y2 minus y1, cy3 plus by2 by c plus b minus y1 by x2 minus x1, cx3 plus bx2 by c plus b minus x1 into x minus x1. So y minus y1 equal to taking c plus b as a LCM in the numerator, similarly in the denominator. So cross multiplying cy3 in the numerator plus by2 minus c plus b into y1 by c plus b. The denominator cx3 plus bx2 minus x1 into cross multiplying c plus b divided by c plus b. So numerator denominator and denominator are same, c plus b, so cancel that one. So you will get y minus y1 equal to cy3 plus by2 minus c plus b y1 by cx3 plus bx2 minus c plus bx1 into x minus x1. So cross multiplying the right hand side denominator to left hand side, cx3 plus bx2 minus c plus bx1, right, into y minus y1, right, which is equal to cy3 plus by2 minus c plus b into y1 into x minus x1. So we are going to separating x term, y term, and without x and y term, that is constant term, right? First, cx3 plus bx2 minus c plus bx1 into that y, right? Y minus y1, so we are multiplying with y. Second, the same term, so minus cx3 plus bx2 minus c plus b into x1 into y1, which is equal to, similarly here also you have to separate like that, cy3 plus by2 minus c plus b into y1, same bracket, into x, minus cy3 plus by2 minus c plus b y1 into x1. So write it in the standard form, x term, y term, then constant term. So cy3 plus by2 minus c plus b y1 into x, right? So taking that y term to the right hand side, right? Minus cx3 plus byx2 minus c plus bx1 into y, then constant term, plus cx3 plus bx2 minus c plus b into x1 into y1 minus cy3 plus by2 minus c plus b into y1 into x1 equal to 0. So cy3 plus by2 minus cy1 minus by1 into x minus cx3 plus bx2 minus cx1 minus bx1 into y plus cx3 plus bx2 minus cx1 minus bx1 into y1 minus cy3 plus by2 minus c1 minus by1 into x1 equal to 0. That is equation number 2. So similarly we can write the equation of other two bisectors. So the equation of BE is ay1, right? Replace y3 by y1, y2 by y3, y3 by y1 by y2, right? So the cyclic order 1 2 3, right? 1 to 2, 2 to 3, 3 to 1, like that. So replace in that, and similarly ABC, so that is also in cyclic order, A to B, B to C, C to A. So instead of C you have to use A, y3 y1, plus instead of B you have to use C, instead of y2 you have to put y3, right? Similarly you can replace all this, ay1 plus cy3 minus ay2 minus cy2 into x minus ax1 plus cx3 minus ax2 plus cx2 into y plus ax1 plus cx3 minus ax2 minus cx2 into y2 minus ay1 plus cy3 minus ay2 minus cy2 into x2 equal to 0. Third equation. Then equation of CF is by2 plus ay1 minus by3 minus ay3 into x minus bx2 plus ax1 minus bx3 minus ax3 into y, bx2 plus ax1 minus bx3 minus ax3 into y3 minus by2 plus ay1 minus by3 minus ay3 into x3. Fourth equation. So to prove these three lines are concurrent, that is 2, 3 and 4. So using now row reduction idea, right? Write the coefficient of x, y, z, right? For the second equation and third equation and fourth equation, like this. So we need to prove this determinant value equal to 0. So for that we are using R1 can be written as A R1 plus B into R2 plus C into R3. R2 and R3 are same as it is. So replacing R1 A into R1 plus B R2 plus C R3. So adding all those things you will get 0 in the 0 0 0 in the first row, remaining all the same thing. So one row is completely 0, so the determinant value is completely 0 because as per the property of determinant, if all element in a row or column are 0, then the value of determinant is 0, right? Hence 2, 3 and 4 are concurrent. That is, the internal bisectors are concurrent. So the point of intersection of internal bisector is called in center of the triangle. Thanks.